All right. Hey guys, just wanted to go through that previous example um, where we wanted to find the regression line, right, for that previous data set, looking at GDP for certain countries and their CO2 emission, right? Um, so as we kind of saw, it has a pretty positive association, right? As GDP is going up, so is CO2 emissions. Um, And there's a bunch of different lines that I could draw, right, to describe how these two variables are related, right? But I want to find the best possible line, right? And that's what the regression line is doing, right? It still has the same type of form that your algebra equation for a line in algebra kind of look like. So y equals mx plus b. Um, Still has that same form. It's just a matter of finding m, which is your slope, right? And b, which is the y-intercept. All right. And these things kind of have a bit of a different way to find them than you probably did in algebra, right? They have a bit more complicated equations. So if you've kind of gone through the previous pages, right, the slope is your sample correlation, the R times SY over SX, where these are just the standard deviation of your Y values, standard deviation of your X values. So I've got to find a couple things there and just multiply, divide, make sure everything is set up correctly. And then from there, I can find the y-intercept, right? So this is the sample mean of the y values minus this slope. So I have to find this slope first, right? Because I can't find y-intercept without plugging this number in, times sample mean of the x values, right? Yeah, a couple of different things involved, and it's just a matter of kind of finding each of the individual values and then plug in everything in. So yeah, what do I need? I need Sx, Sy, I need mean of the x values, mean of the y values, and I need correlation, right, R. Yeah, so very helpful to have Excel or Sheets kind of available to do this, right? If I hit equals stdv.s, that's what I can use to find standard deviation. And I just have to do this for both columns, right? The x values and the y values. In this case, I'm using GDP as my explanatory variable, right? This is the x-axis, to explain how high CO2 emissions are, high or low, right? So GDP is my x values, and then I also have to do it for my y values, the CO2 emissions. Okay, also I have to find the mean, right? So in Excel, that's equals average. I think in Sheets, it's just equals mean. And I just do this for the x values, do this for the y values. Same thing we've been doing since chapter 3. Mean and standard deviation, right? And then R is correlation. That's the new command we've kind of started looking at. And that's equals coral. And you just have to select both of these columns. Doesn't matter what order you do it in. Again, I can do it for CO2 first and then GDP. And that'll give me positive 0.87 for my correlation, right? So pretty linearly associated, right? They seem kind of spread out. But for the most part, you can kind of imagine a line that crosses pretty close to most of the points, right? And then from here, it's just a matter of going back to those previous equations for mean and y-intercept, sorry, not mean, slope, and plugging in everything correctly, right? So slope is going to be correlation times your SY divided by SX, all right? And you'll get 199 for slope. What is this kind of referring to, right? This is how how much CO2 increases if you go up 1 unit in GDP, right? So if I start at 0 and go to 1, this is telling me CO2 will increase about 200, right? And you can kind of see it by this point. If I go from 0 to 1, it's almost kind of referencing that point, right? It's just determining how steep that line will be increasing. Y-intercept will be the mean of my y values minus my slope. So I have to use my slope to find my y-intercept, and then just multiply that by the mean of the x values. Rocky! Sorry, I don't know if you guys picked that up. My dog's going. Okay, he's just gonna keep drinking water. Cool. Hopefully that's not too loud. Yeah, so y-intercept. That is my y-intercept. This is where my line will cross the y-axis, right? So when x is equal to 0, right, when I have a GDP of 0, which maybe isn't really realistic, that is probably bad if that's negative, right? Your CO2 will be around 56 in terms of millions, right? But just telling us where this line is going to cross this y-axis. All right, and those are pretty much your two values, right? You have your m, you have your b. You pretty much have the equation for your line. It's nice to just have the two values, right? But it's also equally nice to write out the equation and kind of know what what the equation of your line is, right? So it's just using the same format that you kind of might remember from algebra. Y equals m. And excuse my handwriting here. It's kind of hard to write with a mouse. So 199.53. Let's just do 2 decimal places. So m times x, right? So here you don't need to replace the y and the x, right? These are just variables that are telling you how your equation is kind of set up, right? You can plug in values for x and kind of see what y is, similar to what you probably did in algebra, right? But that we'll kind of talk about that later. So keep x and y pretty much as you see it. And then you have y equals mx plus b. This is 56.04 if we round to the second place, right? So this is your m, this is your slope, this is your b, your y-intercept, right? And this equation is kind of telling us how your two variables relate, right? The x, remember, is your explanatory variable. This is the GDP. So GDP is your x, right? As x is increasing or decreasing, this is affecting, not necessarily affecting, but this is describing how the linear relationship is set up, right? So y is your CO2 emissions, right? Yeah, and this is the kind of poorly written out equation of the regression line, right? Relating how GDP is kind of associated with your CO2 emissions, right? If you were to kind of plot this line onto your scatter plot, you would have your regression line, right? I'm not sure if this is what Excel does, but they have a little option here in the charts for trend line. Not sure how they find this line, but seems pretty on point here, right? It seems pretty close to all the points there, right? Your regression line is just minimizing the distance from each of these points to the line, right? Yeah, it might not be exact, but we pretty much have the equation for it if we wanted to, right? Yeah, next up, we'll kind of talk a bit about how to use this equation a bit more, right? It's nice that we have an equation, but how can we use it? But that should do it for actually finding it, right? So let me know if you have any questions, and yeah, that should be it for this video.